All right, find the points of intersections between that and sketch a graph to demonstrate the result. Okay, so we have to set the two equal to each other and get it equal to 0 because it's quadratic. So we'll have x squared minus 8x plus 12. And we know that this factors to -6 and -2. So x is 6 and x is 2, and we have to substitute this back into either function. So we're going to have f at 6. I would obviously do it in the line because it's easier. You don't have to square anything. 18 minus 9 is 9. So 1 point of intersection is 9. 6, 9, sorry. And if we did f at 2, that's 3 times 2 minus 9. 6 minus 9 is -3. Okay, so if we didn't care much about how the quadratic looks and the line, we would just have 3x minus 9 and something like this maybe. So 2 -3 here and 6 9 here. Okay, obviously this is not great because that should be 3 for the y-intercept. We would also need the minimum vertex, and we would want both x-intercepts if we were properly sketching this. This is -9. So not great, but that's fine. Use your calculator if it asks for a proper sketch. So for this one, we would set them equal to each other, and we would get it equal to 0. So this is plus 16. So this is factoring to x minus 4 squared. So that means we have just one intersection at x equals 4. And if we do it into the line, we're going to get -1. So the point of intersection is -1. So if we graph this thing, it's similar to the previous one, except we're just intersecting at 4, -1. So I just threw this into the graph just to do a quicker, more accurate sketch. So it's looking like this. So it's like tangent there, and that's the point for -1. So, all right, find the points of intersection, if any, and sketch a graph. So we have x squared minus 5x plus 3 equals 3x minus 15. Subtract 3x and add 15. So if we, so because they say if any, if we did b squared minus 4ac, that would be b squared minus 4ac, and that is going to be a negative number, isn't it? So there are no intercepts. And if you graph this, it's looking like this, and then we'd have something like that probably, okay? Because the previous one was 3x minus 13, so this is still 3x, but moved down 2 to -15. Okay, so x squared minus 3 equals 5 minus x squared. So if we get it equal to 0, that's 2x squared minus 8. Factor out a 2, and that's a difference of squares here. So we're going to have x plus 2, x minus 2, and that means x is -2 or x is 2. And if we substitute that back into either, -2 squared minus 3 is going to be 1. So that's 1 point of intersection, and 2 squared minus 3 is also 1. So 2, 1 is the other one. So this is going to be, when we get into transformations, you'll recognize these quicker, but this is the x squared graph moved down 3. And this is the x squared graph moved up 5 and flipped. So we will have something like this, where that's 5, and this is 2, 1, and this is negative 2, 1. Okay, work with discriminant. Quadratic equation has exactly one solution. For x, find the value of k. So we've got b squared minus 4ac, and that's going to be equal to 0 because it's got one solution. And pay attention to this. So we're going to have 16k squared minus 16 times 9, which is 144. And if we, this is a difference of squares, so we're going to have 4k minus 12 and 4k plus 12 equals 0. So k is going to be either 3 or k is negative 3. So we take that one because k is greater than 0. For 40, we have exactly one solution. So we're going to have b squared minus 4ac equals 0. So 9 minus 4k. So we're going to have k is 9 over 4. All right, if it has, so it does have 2 equal roots, find the possible values. So 2 equal roots means it has, yeah, it's still equal to 0. Okay, so we're going to have b squared minus 4ac equals 0. Equal roots, just to draw a picture, it's like that, where you just have, you know, if it's x minus 2 squared, like that, that's equal roots. So, yeah, so if we expand this out, we're going to have k squared minus 6k plus 9 minus 4k is 0. So k squared minus 10k plus 9, and this factors to k minus 9, k minus 1. So k is 9 or k is 1. Now it says write down the values of k for which x squared plus k minus 3x plus k has 2 equal roots. Okay, so if we relate it to this one, b squared minus 4ac, it's the same thing, equals 0. So that's going to be k is 9 or k is 1 as well. All right, 42, this one, the equation has 2 equal roots, find the value of k. So we're going to have b squared minus 4ac equals 0. So 16k squared minus 8k is 0. Factor out 8k, so we're going to have 2k minus 1. So k is 0 from this one, or k is 1/2. The line y equals p intersects the graph of f. Find all possible values of p. All right, so if, okay, I think this 0 shouldn't be here, and also this, because k can't be 0, so okay. All right, so k is 1/2. So if we find f at x, we're going to have 2 times 1/2, which is 1, minus 4 times 1/2, which is minus 2, plus 1. So the line y equals p intersects the graph of f. Find all possible values of p. So we need, so this graph here, by the way, we can write like this. So this graph has one root, so the y-intercept is 1 from this, and it's got a vertex of 1, 0. So if the line y equals p intersects the graph at f, it has to be, so y equals p is a horizontal line, so at the bare minimum, it has to be here, and it can be anywhere above that. Okay, so as long as P is greater than or equal to 0, it will intersect the graph of F once or twice. So for 43 has two distinct roots. That means the discriminant is greater than 0. So we're going to have b squared minus 4ac greater than 0. So that's 4k squared minus 4 greater than 0. Factor out of 4, k squared minus 1. So we will have k plus 1, k minus 1. Now, don't just say k is negative 1 or 1, because we have roots at negative 1 and 1. This is opening up because there's a positive 4. And we have either x is less than negative 1 or x is greater than 1, because this is when that is positive. So a family of functions is that where k is 1 to 7. Find the possible values of k if the k is an element of 1 to 7. That's set. Find the possible values of k if the curve of this function crosses the x-axis. So we would want this equal to 0, because that is the equation of the the x-axis. And we can find the discriminant of this. So it's going to be b squared minus 4ac, and we need this to cross the x-axis. So we need it greater than 0. So that's 9 minus 4k greater than 0. So we're going to have that k is less than 9 over 4, which is 2 and a fourth. So k can either be 1 or 2. Okay. So 45. The equation has two distinct real roots. Okay, so we have b squared minus 4ac is greater than 0. So 9 minus 4k squared minus 8k. So I'm going to get everything over here. So 0 is greater than 4k squared plus 8k minus 9. And then we can factor, which it doesn't factor. So I put it into the graphing calculator. If you go to a regular calculator screen and push menu 331, and it's degree 2, so just push OK there, you get that k is negative 2.80 or 0.803. And then we graph it because it's an inequality, and it opens up because a is greater than 0. 1, it's positive. Yeah, greater than 0. So then you know this is less than 0 in between negative 2.80 and 0.803. So that is your answer. All right, 46. The functions defined by that, find the set of k, so it's got two distinct roots. So we're going to have b squared minus 4, a is 1, c is k times 3k plus 2. So that's 4. Oh, and we want this greater than 0. So that's 4, and that's going to be minus 12k when we distribute the negative 4k. Okay, squared, sorry. So negative 12k squared minus 8k. And this is also with graphing calculator, so I'm not going to bother doing anything else. I'm going to go menu 331, enter, and it's negative 12, negative 8, and positive 4. And if you control enter that, you get that k is negative 1, or k is 1/3, or 0.33333. So we want this to be greater than 0. So it's at negative 1 and 1/3, and it's opening down because negative 12. So if we want that greater than 0, that's happening in between negative 1 and 1/3. So for 47, consider this equation for which the equation has real roots. So we want it greater than or equal to 0, the discriminant. So we're going to have b squared minus 4ac greater than or equal to 0. So take this thing one step at a time. 100, and if I distribute the negative 4, it's going to be minus, actually, I'm going to do minus 4 later. I'm going to distribute this out. So we're going to have k minus 2 plus 2k squared minus 4k. And if we now distribute the negative 4, so minus 4k plus 8 minus 8k squared plus 16k. And then we'll get like terms together. So that's plus 12k plus 108, and we want that greater than or equal to 0. It's with calculator. So menu 331, enter, and we've got negative 8, 12, and 108. And we get that k is negative 3 and 4.5. So there's negative 3, there's 4.5. It opens down because of the negative 8, and we want it greater than 0, so that's in between negative 3 and 4.5. All right, we've got this function, no roots, so we want the discriminant less than 0. Okay, so the quadratic function is defined by that. Determine the values of k for which q to x equals 0 has no real roots, so we need the discriminant less than 0. So we're going to have b squared, so k minus 3 squared, and I know it's negative, but a negative squared is positive, so it doesn't matter. So b squared minus 4ac is k minus 8, and we want that less than 0. So this is going to be k squared minus 6k plus 9, and distributing the negative 4k, we're going to have minus 4k squared plus 32k. And if we get everything, so this is with graphing calculator, so it doesn't matter. We'll get the terms together. So we're going to have negative 3k squared plus 26k plus 9 less than 0. So in the calculator, I do menu 331, enter, and you get k is negative 1/3 and 9. So then if we have negative 1/3 here, 9 here, it's opening down because of the negative 3 is a. And if we want it less than 0, it's k is less than negative 1/3, or k is greater than 9. All right, so 49, given that, find the range of values of k for which f at x is greater than 0 for all real values of x. So for this one, if f at x is greater than 0, then the whole function lies above the x-axis. So we need the discriminant less than 0. So we have b squared, which is 2 minus k squared, minus 4ac is k squared, and we want that less than 0. So this is going to be 4 minus 4k plus k squared, and then minus 4k squared less than 0. So we're going to have negative 3k squared minus 4k plus 4 is less than 0. And we can probably factor this because it says with or without graphing calculator. So if I have negative 3k and k less than 0, and I want to multiply to 4 and add to negative 4, I'm going to have 2 here and 2 here because I want negative 6 and a positive 2. So if you distribute this out, it would be the thing above, okay? So we're going to have that our zeros are going to be k is 2/3, or k is negative 2, and if that's 2/3, that's negative 2. A is negative 3, so that's opening down, and we want it to be less than 0, so that's happening at k is less than negative 2, or k is greater than 2/3. So for this one, find the range of values of m such that for all x, that. So if we distribute the m and we get it on one side, so x squared minus mx minus m, and then if we want that function greater than or equal to 0, that's saying it needs to be like that, okay? So we want the discriminant, b squared minus 4ac, to be less than or equal to 0, because it can lie on the x-axis or be above it, okay? So m squared plus 4m, factor out an m, and m is either 0 or m is negative 4. So 0 or negative 4, and since a is positive, it opens up, and we want this less than 0, so that's happening in between negative 4 and 0. All right, for what values of m is the line y equals mx plus 5 a tangent to the parabola y equals 4 minus x squared? So if it's tangent and intersects at one point, so we set these equal to each other, and we have negative, and get it equal to 0, so negative x squared minus mx, and then 4 minus 5, negative 1, so that's equal to 0. And we would want to find the discriminant of this such that the discriminant is equal to 0, because that's one intersection. So we'll have b squared minus 4ac equals 0, because it's tangent intersects once. So m squared, that's going to be minus 4 is 0. So m is going to equal plus or minus 2. The parabolas, that and that, have only one common point. They are tangent to each other. Find the value of m. So we set them equal to each other to find their intersection and get them all on one side equal to 0. And we find the discriminant and set it equal to 0. So that's an x, sorry. All right, so b squared minus 4ac, and that's equal to 0. So 4, and distributing the negative 4, we're going to have plus 4 minus 4m, and that's 8 equals 4m, so m is 2. All right, long question. Write down the coordinates of the vertex of the curve at f. So that is 4, positive 8. B, given the f at 7, okay, so we've got negative 10 equals a. X is 7 minus 4 squared plus 8. So negative 10 is 3 squared is 9a plus 8. Subtract 8 and divide by 9 is going to be a is negative 2. So for C, hence find the y-intercept of the curve. So we've got f of x equals negative 2 x minus 4 squared plus 8. If we substitute in 0 for x, we can find the y-intercept. So that's 16 times negative 2, which is negative 32, plus 8 is going to be negative 24. So that's the y-intercept, 0, negative 24. All right, D, find the x-intercepts of the curve. So that's when we set y to 0, negative 2x minus 4 squared plus 8. All right, if we subtract 8, divide by negative 2, square root both sides, so plus or minus 2, and then add 4. So we're going to have 2 plus 4 is 6, and negative 2 plus 4 is 2. So the x-intercepts are 6, 0, and 2, 0. Now if we want to sketch the curve, we're going to have y-intercept negative 24. Vertex is 4, 8. The x-intercepts are 2, 0 and 6, 0. And that's that. Something like that. Okay, 54. We've got rational numbers, that's fractions. The point P, negative 4, 3 lies on the curve, show that. Okay, so we have for A, 3 equals A times negative 4 squared plus B times negative 4 plus C. So 3 is 16A minus 4B plus C. For B, those also write down two other equations. Okay, so we're going to have 3 equals A times 6 squared plus B times 6 plus C. So 3 equals 36A plus 6B plus C. So this is the first. This is the second. And we have negative 1 equals A times negative 2 squared plus B times negative 2 plus C. So negative 1 is 4A minus 2B plus C. That's the third one. Hence, write down two other linear equations. Hence, find f of x. Okay, so if you're doing this in the calculator, you need to go to Menu, Algebra, solve system of linear equations, and we have 3 of them. And you can change this to A, B, C. Okay, enter. All right, so then we just type the things in. So we have 3 equals 16A plus, nope, okay, whatever, negative 4B plus C. And tab to the next one, we've got 3 equals 36A, 36A plus 6B plus C. And last one is negative 1 equals 4A minus 2B plus C. And that's that. So there's your answer. So A is, okay, we can just type it straight in, or write it straight in. So for C, f of x is going to be 1/4 x squared minus 1/2 x minus 3, and they're clearly rational numbers. Write it in that form. Okay, so we need to factor out the 1/4. So negative 1/2 divided by 1/4 is negative 1/2, oops, times 4/1, so negative 2, x, and then leave that, minus 3, and then we do half the middle term squared, so that's 1, but we didn't add 1, we added 1/4, so we have to subtract 1/4, so we're going to have 1/4. This factors to x minus 1 squared, and then that's going to be, if we make that the same denominator, that's 12/4, so minus 13/4. So that's that in vertex form. All right, consider two different quadratic functions of that form. The graph of each function has its vertex on the x-axis. Find both values of q. So if the vertex is on the x-axis, that means the discriminant is equal to 0 because it has one solution. So for A, we have b squared minus 4ac equals 0. So that's q squared minus, that's 400 equals 0. So q is going to be plus or minus 20. For b, for the greater value, solve f at x equals 0. So we have f at x is 4x squared minus 20x. The greater value is 20, so minus 20 plus 25. Now this is one of these perfect square trinomials. You can use graphing calculator, it says you can, but you should know this. This factors to 2x minus 5 squared, 2x minus 5, okay? So x is going to be 5/2. C, find the coordinates of the point of intersections of the two graphs. So we'll have 4x squared minus 20x plus 25 equals 4x squared plus 20x plus 25. So those cancel, and if we have 0 equals 40x, x is 0, and we just substitute it in to get 25. So it should be 0, 25. So if we want to sketch the graphs, we have that the intersection of the two is 0, 25, and that's also the y-intercept for both graphs. For the one with, from the one we did with B, the vertex is 5/2. So this one's looking like this, something like that. And then if we were to graph the, find the other x-intercept or vertex, it would be negative 5/2. So that's this one. Okay. All right, find the values of m for which the line y equals mx plus 1 is tangent. So that means that 3x squared minus x plus 4 equals mx plus 1. So 3x squared minus x minus mx, and then subtracting 1, we've got plus 3 equals 0. So 3x squared, if we factor out an x, we're going to have negative 1 minus m. Hope that's a plus in between, sorry. And then plus 3. So we are going to have one intersection, so the discriminant, b squared minus 4ac, is going to be equal to 0, okay? So we will have 1 squared plus 2m plus m squared minus 36 equals 0. So m squared plus 2m minus 35 is 0, and m plus 7, m minus 5. So m is negative 7 or m is 5. For meets the graph of f, I think that means it just, intersects it twice. So we would have the discriminant greater than 0. So for this one, we'd have m squared plus 2m minus 35 greater than 0. We already know the intersections are negative 7 and 5. It opens upwards, and it's greater than 0 when m is less than negative 7 or greater than 5. That's for B. A double I. This is AI. And then doesn't meet the graph, that is when, A triple I, that's when the discriminant is less than 0, which is in between from our graph negative 7 and 5. For each value of m found in question AI, find the common point of the two graphs. So for that one, if we had 3x squared minus x plus 4 equals negative 7 x plus 1. All right, so 3x squared plus 6x plus 3 equals 0. Factor out a 3, x squared plus 2x plus 1. And this factors to x plus 1 squared. So x is negative 1. And if we substitute that back into either graph, obviously the negative 7 times negative 1 plus 1 is the easier one. That's going to be 8. So that's one point of intersection if m is negative 7. All right. If m is 5, we would have 3x squared minus x plus 4 equals 5x plus 1. And we'd have 3x squared, and that'd be minus 6x plus 3. So here we're going to have x minus 1 squared. So x equals 1. And if we substitute it back into the line equation, we get 6. So that's the other intersection.